Welcome back to another edition of Notes that we're going to be covering Chapter 4.2, Solving Inequalities, and using addition or subtraction when doing so. So, if you remember back when we did the solving equations with adding and subtracting, we learned about a few properties. We had the addition property of inequality, or the addition property and the subtraction property of equality. Now we're doing the addition property and the subtraction property of inequality. It basically tells you that when you add the same number to each side of an inequality, the inequality remains true. So whatever you add to one side, if you add it to the other side, the inequality remains true. The same thing happens with the subtraction property of inequality. If you subtract the same number from both sides, they remain true. It remains balanced, if you remember that. Okay? And this is also true for less than or equal to and greater than or equal to. Okay? Just some basic properties. So we're going to jump right into this. I think the best way I can tell you is when we're dealing with adding and subtracting inequalities, the rules are pretty much the exact same as the rules with equations. We're going to treat it the same way. So let's do this first inequality together. I know it's posted up here, but we're going to go ahead and try it together just so you can see me walk through step by step, all right? So we start off with the inequality x minus 5 is less than negative 3. Okay, so much like with an equation, I want to get that x by itself. That is my goal, is to get, isolate the variable. So the opposite of subtracting, or the inverse of subtracting 5, is to add 5. So I'm going to add 5 to the left-hand side, and whatever I do to one side, I have to do to the other side. So I'm going to add 5 to the other side. So these this minus 5 and plus 5, they cancel out, leaving us with an x is less than. And negative 3 plus 5 leaves us with a 2. So my solution set would be x is less than 2, which tells me all numbers less than 2 would be a answer or solution that would satisfy this inequality. Now, the way I graph it, since it's less than, I use an open circle. And since it's less than and the x is on the left-hand side, I can say the arrow is going to go to the left. So if we look over here, you'll notice that it's going to the left and it's an open circle. That's basically all you have to do. So, you know what time this is. I want you guys to go ahead and try 1, 2, and 3 on your own. See how you do. So pause it, and we're going to come back and see how you did in just a moment. Okay, let's take a look to see how your work turned out. So for number 1, we have y minus 6 is greater than negative 7. So since I'm subtracting 6, I'm going to add 6 to both sides. So plus 6 and plus 6 over here. The 6 is on the left-hand side, cancel out, and leave us with a y is greater than. And negative 7 plus 6 gets us negative 1. Now remember, when we're doing these inequalities, you are more than welcome to use the Desmos calculator. But once again, I'm going to tell you we're not using the other calculator for the test, so you need to get used to that Desmos calculator. So you may use it, but that's it. It also tells us we need to graph the solution. So I'm going to go ahead and make a number line. If you remember from 4.1, we remember how to make these number lines. So I told you could just write 3 little hash marks here. And we're going to put the solution on the right-hand side. We're going to put that here in the middle. So I'm going to make that a negative 1. And then to the right, I'm going to put a 0. It's the next number to the right. And then to the left, I'm going to put a negative 2. That's the next number to the left. And I'm going to go ahead and graph it. Since it is greater than, it's going to give me an open circle. And greater than, since the y is on the left-hand side, I can follow the arrow. And it tells me that y, all solutions are greater than negative 1, so it's going to go to the right. And so that's how my equation, or that's how my graph of the number line should look. All right, let's try our next one. For this one, we start off with subtracting 3.8. So we're going to go ahead and add 3.8 to both sides. So add 3.8 here, add 3.8 there. The 3.8s cancel out, leaving me with b is less than or equal to, well, it looks like 1.7 plus 3.8 would give me 5.5. So it's time to graph it. So I'm going to go ahead and make my number line. And again, I have a couple choices on how I can number these. I'm putting the 5.5 in the middle. And either way, how I'm going to describe, you can do, and it's perfectly fine. If you wanted to go up by tenths and make it 5.4 and 5.6, you're more than welcome. Me personally, I'm going to have mine go to 6 and 5. It really makes no difference. Either way, you're fine. So just make sure you're going up by the same amount, going to the left and going to the right. That's all that I'm asking. And it's a logical decision. I wouldn't want to see you do 4.5, 5.5, and 6.5. It's just kind of an odd way of putting it. I think that that'd be something you wouldn't write. You wouldn't want to write your number line with those type of numbers personally. So let's go ahead and write our graph here. We're going to graph this solution set. So since it's less than or equal to, I'm going to use a closed circle. And since the B is on the left-hand side, I can go ahead and have my line go the direction of the arrow, which is to the left. And again, a way of looking at this is B is saying it is less than or equal to 5.5. That means that any number that is 5.5 or less would be a solution. That's why my number line goes to the left. All right, let's try one more, see how you guys did on this one. So we have negative 1/2 is greater than z minus 1.4. Now, at some point, I would suggest that you flip this inequality. So I'm going to flip it now, just to get it out of the way. So I'm going to write z minus 1/4. And you'll notice that the less than part of the inequality sign is pointing at the z. So you want it to point this way as well. So I'm going to flip that sign. And I'm going to write, instead of writing negative 1/2, I know I'm going to have to subtract or add my fractions, so I want them to have the same denominator. So I'm going to go ahead and just make this into a common denominator 4, and so negative 1/2 would be negative 2/4. I'll just get that out of the way right now and save myself the trouble. So, since I'm subtracting 1/4, the inverse of that would be adding 1/4. I'm going to do that to both sides, because whatever I do to one side, I must do to the other. And once I've done that, I can go ahead and cross out my fourths, leaving me with a z. And I can bring down my less than sign. And negative 2/4 plus positive 1/4 gets me negative 1/4 as my answer. I can go ahead and graph this now. So I'm going to draw my number line. I'm going to mark 3 on here. And I have the negative 1/4 in the middle. I'm going to go up by fourths. So to the right of it, I'm going to have 0. And I could either put negative 1/2 or negative 2/4. I'm going to just put negative 2/4 over here, so not to confuse anyone. So you can see exactly it went up and down by a fourth. And so now I'm going to go ahead and graph my solution here. So since it is less than, it's going to be an open circle. And since z is less than, and the arrow is pointed to the left, and the z is on the left-hand side, I can go ahead and draw my circle and my line going to the left. Okay? Hopefully that makes some sense to you. Hopefully you did pretty well. Let's go ahead and move on. So our second example here, we now have 13 is less than or equal to x plus 14. And again, I'm going to go ahead and rewrite this. So I start off again with 13 is less than or equal to x plus 14. I'm just going to rewrite it and do x plus 14. And it's not going to be greater than or equal to 13. And again, the reason is the the wide part of the inequality sign is facing the x in the green example. And so in the red example, it still must have the open part, or the wide part of the inequality sign facing where the x is. Okay? So now we can begin our inverse operation. And so I'm going to subtract 14 because that's the inverse of adding 14. So I'm going to do that on both sides. And these cancel out, leaving me with an x, and I can bring down that greater than or equal sign. And 13 minus 14 gets me -1. And so you can see the answer right over here is x is greater than or equal to -1, just like we got. Since it's the greater than sign, I'm going to darken in my circle. And since the arrow is going to the right and my x is on the left-hand side, I can have it going to the right. Okay, so let's move on to our next page here. Here you have 3 more problems to try out on your own. So take a moment and do so yourself and see how you do. I'm going to pause it. All right, let's see how you guys did. For our first problem, we have w plus 7 is less than or equal to 4. So I'm going to do the inverse of adding 7. I'm going to subtract 7. I'm going to do that to both sides. And the 7 minus 7 cancels out, leaving me with w is less than or equal to. And then 4 minus 7 gets me -3. And now I can graph my answer on my number line. All right, so I have my -3 here in the middle. The next one higher to the right will be -2, and the one to the left will be -4. All right, and let's go ahead and graph this. So it's less than or equal to, which means I'm going to have a circle that's filled in, and it's going to go to the left because it's less than or equal to. So it tells me that any number that falls to the left of -3, but it will also include -3, all of those are possible solutions. That means you can put any of these answers back into that inequality and you can check it. And this is probably a good time to mention to you, when you go to check your answers, do that. You know, if you want to be positive you have the right answer, you know, make sure you didn't have the arrow going the wrong way. You can just pick 2 numbers, or 1 or 2 numbers, or however many you like, from your solution set found on the graph. Just pick a couple of them, one of them, put it back into the inequality, make sure that it works. And if you want to be completely positive, pick one from the other side to make sure that the other side does not work. And you'll see if your answer is correct or not, if your solution set is good to go or not. So just a little tip for you to check your answer. Okay, number 5 here. The D is on the right-hand side. I don't like that, so I'm going to go ahead and switch it. I'm going to put my D plus 10 on the left-hand side. You'll notice that the inequality sign is pointing to the D, so I'm going to go ahead and make it point this way. I'm flipping it, and it's going to equal 12.5. And now I can do the opposite, or the inverse of adding 10. I'm going to subtract 10 from both sides, which will get me D on the left-hand side, and it's less than or equal to, sorry about that. And then 12.5 minus 10 would get me 2.5. And that's my solution. So I'm going to go ahead and post it here on my number line. I'm going to put my 2.5 in the middle. I'm going to go up by 0.5 again. So I'm going to make this 3 over here and 2 over here. And it is closed because it's less than or equal to. And it's going to go to the left because D is less than or equal to 2.5, which tells me all solutions, including 2.5 and less, all would work with this inequality. Okay, our final one on this page, and we'll be almost done. So, all right, I noticed a few things. First, I noticed that we're dealing with fourths. So I'm going to go ahead and do this. I'm going to change it right here from the get-go. I'm going to make my 1/2 into 1 2/4. But I'm not done yet. Now I'm going to rewrite it. I know it's multi-step, several things to do. I'm going to rewrite it now and watch what I do. I'm going to say x plus 3/4 is greater than, and 1 2/4 is the same thing as 4 times 1 is 4 plus 2 is 6, so 6/4. I'm just trying to think ahead and think I've got to show this work myself. Therefore, I'm going to go ahead and make it into improper fractions. It's easier to deal with for me. So I can go ahead and I can subtract the 3/4 and watch how easy this is now from both sides. And when I do this, let's see, these cancel out over here, giving me x is greater than 6/4 minus 3/4 gives me 3/4. See how easy that was? My son would say, easy peasy, lemon squeezy. All right, maybe not the lemon squeezy part, but whatever. All right, I'm going to go ahead and put my solution over here. So I have 3/4. This would be 4/4. And you can either do 4/4 or 1. Either way is fine. I'm cool with either way. And this would be 2/4. Or if you really want to, you could put 1/2. So, I mean, if you wanted to, you could put 1/2, 3/4, and 1. I really don't mind. It doesn't matter to me which way you go here. I'm going to go ahead and graph this. It's going to be open because it's greater than. And it's going to go to the right because x is greater. All the solutions are greater than 3/4. So it looks like this. Okay? I hope you got all three of these correct. If not, if you missed any of them, I hope you understand what you did wrong. And if not, watch it again. And if not, you can ask me in class. It's fine. Okay, so we get to the word problem. Fear not. There's an astronaut. How bad could it be, right? Okay, final question that we'll do together, and then we have one more to try on your own, and then you are done. Okay, so a person can be no taller than 6.25 feet to become an astronaut pilot for NASA. Your friend is 5 feet 9 inches tall. Write and solve an inequality that represents how much your friend can grow and still meet the requirement. Okay, so we have a couple of things going on here. I want you to notice that first we have 6.25 feet. And then we also have 5 feet 9 inches. These are comparable, but they're a little bit off from each other. The way I look at it is I'm going to have to convert that 9 inches into feet because the 6.25 feet is all in feet and the other one is in feet in inches. So I want to make them the 5 feet 9 inches into feet. Now, here's a couple ways of looking at it. I know that 5 feet 9 inches is the same thing as 5 feet and 9/12 inches, right? Because 9/12 is the same thing as 9 inches because there's 12 inches in a foot. And since I'm dealing with a decimal with the 6.25, I'm going to go ahead and convert this 5 feet 9/12 inches into a decimal. 9/12 is the same thing as 3/4 or 0.75. So this is 5.75. So hopefully you understand how I'm changing it and why I'm changing it to this. So this leaves me with the equation of well, let's take a look at this. So we're going to write and solve an equation to do this. So first things first, we need to identify what our variable is. So our variable, we can use x, h, g, whatever you really want. I'm going to put an x here. I'm going to say x would represent the amount he can still grow. Okay. That's what he can still grow. We don't know what that amount is yet. That's our unknown. And it's what we want to try to find out. And so what do we know? Well, we know this. We know that you can be no taller than 6.25. So 6.25 is my constant over here. And no taller then means it can be the same, but it cannot be taller. That means it's going to be less than or equal to. It can be less than 6.25 feet. It can't be more, but it could be the same. That's why it's less than or equal to. And now I'm going to look at what is his current height. Well, his current height is 5.75. and he can still grow the unknown amount, which is x. Okay? Once we do that, we can go ahead and undo this problem. So we're going to subtract 5.75 from both sides. And when we do that, we're left with x is less than or equal to 0.5. Now, what does 0.5 mean? Well, I guess what we kind of failed to mention is in the beginning when they said it was 6.25 feet and we had 5.75 feet, we're dealing in feet. So the amount he can grow, this is in feet. So our answer is in feet. So your friend can still grow 0.5 feet, which is the same thing as 6 inches or 6 inches. Okay? I'm sorry this is taking a little bit longer. Remember, you can fast forward if you need to. I'd rather be thorough and let you make those type of decisions. So I want to make sure I cover everything for you guys. I hope you understand. So let's go ahead and look at the last problem that you're going to do. It's based on the same information. So you read this question and you go through it and see how you do. And we're going to check in here in just a moment. Looks like we are down to our final problem. Let's knock this one out, okay? Okay, so your cousin is 5 feet 3 inches tall. Write and solve an inequality that represents how much your cousin can grow and still meet the requirement of being an astronaut. So we're referring back to example number 3, and if you recall, that astronaut can be up to 6.25 inches. So again, we're going to start off with having our unknown. We can call it x, g, h, whatever you want. I'm going to call it x. I'm going to again say this is the amount. Having a hard time writing right now. Let's try this let's try this again. This would be the amount. I apologize for this. It's not writing very easily. This is the amount he can still grow. Hoping you can appreciate my challenges with my cheap stylus. It doesn't work if the iPad isn't at the right angle. Okay, so anyway, like whatever, move on. So let's go ahead and write our inequality. So again, we know that he cannot go above and beyond. He cannot be any taller than 6.25. We knew that from the last problem. It can't be any taller than 6.25 feet, right? In feet. We're dealing with feet. Okay, so where is he right now? Well, currently he's 5 feet 3 inches. So let's look at this. 5 feet 3 inches is like 5 feet and 3/12 inches, which is the same thing as 5 1/4, which is the same thing as 5.25, right? So 5.25. So we're going to do 5.25, and he can still grow that unknown amount. And now we have an inequality that we can solve. So if we add 5.25, we're going to undo it by subtracting 5.25 from both sides. These cancel out, and I'm left with x is less than or equal to 1 or 1.0, however you want to look at it. Should have just did 1. 1 or 1.0. You know what, I'm going to go ahead and erase that. That just looks sloppy. How about it's 1, right? X is less than or equal to 1. And so what does that mean? This means he, or your cousin, can still grow up to, oh my goodness, having a hard time here. Let's say can still, that's an O right there, grow up to 1 foot. Or 12 inches. Okay. I hope this made sense to you. I hope you guys did well on this. And if you have questions, just ask me in class. Best of luck and have a great night. All right, bye-bye.